Hi students, how are you? Hoping all of you are doing very well with your studies. And this is our 15th lecture of electric potential and capacitors. Okay. And in the previous lectures, we were discussing about the capacitors. And we have almost completed the topic capacitor. And a little bit of topic is pending. And before starting today's topic, this is our channel, Physics Gallery, Asha Binu. Hoping all of you are going very well with your studies, and at the same time you will have some entertainment also. Okay. So in this lecture we are going to sharing of charges. We are going to sharing of charges. Okay. That is, suppose we have got two capacitors. Sharing of charges. Suppose we have got two capacitors. The first capacitor of capacitance C1 and the second capacitor of capacitance C2. There are two capacitors. The first one of capacitance C1 and the second one of capacitance C2. The first is at first connected to a battery of potential V1 and is closed, so that due to this potential V1, it stores a charge Q1. It stores a charge Q1. Okay. So the first capacitor of capacitance C1 is connected to a battery which provides a potential V1, and when the battery is connected, the capacitor stores a charge Q1 in it. Similarly, the second capacitor is also connected to another battery. It is also connected to another battery which provides a potential V2, and when the circuit is made closed, Q2 charge is stored in this. Okay, that is, the two different capacitors are independently charged. And now the battery is removed. That means now we are removing the battery. Now we got two capacitors. Okay, the first one of capacitance C1 and the second with capacitance C2, where the potentials provided are V1 and V2, and the charge stored in them are Q1 and Q2 respectively. Okay, so now we have got two different charged capacitors, and these capacitors are now connected by means of a connecting wire. These capacitors are now connected by means of a connecting wire. Okay, the two capacitors having different capacitance, providing different potential, and having different charges are connected by means of a connecting wire. What happens? The charge begins to flow from high potential to low potential. The charge begins to flow from high potential to low potential till the potential becomes same. The charge flows because there is a potential difference between the two capacitors. So the flow of charge occurs till the potential difference between them becomes zero. That is, the two capacitors attain a common potential. Okay, and today we are going to discuss about that common potential during sharing. So the topic is sharing of charges. So for that, in order to define that, we have taken two capacitors of capacitance C1, C2 provided with potentials V1 and V2, so that they store charges Q1 and Q2 respectively. Is it clear? And the two capacitors are now connected by means of a connecting wire. What happens? The charges begins to flow from high potential to low potential till they attain a common potential. So we have to discuss about the common potential. This is our equation, a simple topic, but sometimes the question is asked. So the common potential V after sharing. So what is the common potential after sharing? We are taking it as V. So according to our basic equation, C is equal to Q by V. Therefore, V is equal to Q by C. Is it clear? So to find the common potential V, we have to take the ratio of charge to the capacitors. That is, the common potential means the total charge in the system to the total capacitance of the system. Okay, is it clear? So potential V is equal to total charge by total capacitance. And what is total charge? V now equal to Q1 plus Q2. What is the total capacitance? C1 plus C2. The total capacitance of the, suppose this is 2 mu farad and this is 3 mu farad. Now the system contains a 2 plus 3, 5 mu farad capacitance. The arrangement is not series connection. The arrangement is the sharing of charges by two different capacitors at two different potentials. Okay. So now the total capacitance is C1. This is not effective capacitance. This is the total capacitance in the circuit, C1 plus C2. In the arrangement, not in the circuit, in the arrangement. Okay. And how to take Q1 and Q2? So from the equation we can write Q is equal to CV. So Q1 is equal to, Q1 becomes C1 V1 and Q2 becomes C2 V2. Alright, so the common potential after sharing becomes C1 V1 plus C2 V2 by C1 plus C2. So what is the common potential after sharing? Basic equation, important equation. The common potential after sharing of charges by two different capacitors at two different potential is equal to C1 V1 plus C2 V2 by C1 plus C2. This is total charge and this is the total capacitance, but the equation form is like this. Okay, so this is the common potential after sharing. Is it clear? And after sharing, whether the C1 contains Q1 charge itself? No, it is shared between C1 and C2. Similarly, what about the charge in C2? Whether it is Q2 itself? No, it was before sharing. After sharing, sometimes if C1 is at higher potential, it gives it some charges to C2. Or if C2 is at higher potential, charges flows from C2 to C1. Whatever may be, charge is distributed. Charge is flowed from one capacitor to another capacitor. So after sharing, C1 gains or C1 will have a charge Q1 dash, not Q1. It was before sharing. So after sharing, what is the charge on C1? We will take it as Q1 dash. We will take it as Q1 dash. Okay. Similarly, here it will be Q2 dash. Therefore, we will write, run this. So now we will write after sharing, the charge on C1, Q1 dash is equal to, what is the equation for charge Q? CV. So, its capacitance C1 into the common potential. After sharing, both of them have a common potential. So, what is the equation for potential? This is equation. C1 V1 plus C2 V2 by C1 plus C2. Where C1 V1 is Q1, C2 V2 is Q2. Or we can write it is the total charge. May I write the total charge as Q? Okay, is it clear? So, we can write now Q1 dash is equal to C1 into the numerator of common potential contains C1 V1 plus C2 V2. Q1 plus Q2. That is the total charge Q. May I write the total charge as Q by C1 plus C2. So what is the charge stored in the first capacitor after sharing? Q1 dash is equal to C1Q by C1 plus C2. Similarly, the total charge, the total means the charge on C2, Q2 dash is equal to, similarly Q is again CV. For the second capacitor, the capacitance is C2. And we have to take the common potential. Once more, what is common potential? C1 V1 plus C2 V2 by C1 plus C2, or Q1 plus Q2 by C1 plus C2, or we may write the total charge Q by C1 plus C2. So Q2 dash is equal to C2 into total charge Q by C1 plus C2. Okay, is it clear to you? So the charge on the first capacitor after sharing C1Q by C1, here this I will write here, and Q2 dash is equal to C2Q by C1 plus C2. Okay. Okay. This is also not, I will write once more here. Q2 dash is equal to C2 into Q by C1 plus C2. Hoping you can see it clearly. Okay. So, what is the common potential after sharing? The common potential after sharing is C1 V1 plus C2 V2 by C1 plus C2, and the charge on each capacitor after sharing Q1 dash is equal to its capacitance C1 into Q, the total charge by C1 plus C2. Similarly, the charge on the second one after sharing is its capacitance C2 into total charge Q by C1 plus C2. Is it clear? Okay, and during this process, some energy is lost. Yeah, some work has to be done to move charge from one capacitor of higher potential to other capacitor of lower potential. So work has to be done. When work is done, some energy is lost. And what is the lost energy? We have to discuss the loss in energy during this process also. So pause the video, take the notes, clear out all of the topic. Okay. Now we are going to the energy lost during sharing. Loss in energy during sharing. Okay. Loss in energy. Loss in energy during sharing. So how do you find it? That is, what was the initial energy E1? Here it is half C1 V1 square. Here it is half C2 V2 square. So what is the total initial energy? This is initial energy. Initial energy. Okay. Therefore, what is the final energy? Final energy E2 is equal to the first one, half C V square, C1 V square plus half C2 V square, common potential. Okay, is it clear? Or we can write half C1 plus C2 into V square. So what is the loss in energy? The loss in energy, initial energy was high. When charge is shared, energy decreases. So we will write it as E1 minus E2. It is equal to E1 minus E2. And you have to subtract E2 from E1. That is half C1 V1 square plus half C2 V2 square minus half C1 plus C2 into V square. On solving, we will get the loss in energy delta E is equal to, you just mathematically solve it. We just want the equation half C1 C2 by C1 plus C2 into V1 minus V2 the whole square. So what is the loss in energy during sharing? During sharing, the loss in energy becomes equal to half C1 C2 by C1 plus C2 into V1 minus V2 the whole square. It is also in the form of half CV square. This is potential difference. Is it clear? So there is a topic called as the sharing of charges when two different capacitors which are at different potentials having different charges are connected by means of a connecting wire. So here we have to discuss about the common potential after sharing. the cap of my pen falls down, okay, and without that the class never goes. So we have to write the common potential after sharing. Is it clear? The charge stored by each capacitor after sharing, and also the energy lost during sharing. A typical topic in capacitors. Okay, so we have completed that topic, that is sharing of charges. Pause the video, take your own time and take the notes, go through the notes, discuss it, and if there is any doubt, you may ask it in the comment box. Okay. And during my rubbing, may I ask you, how are your studies going on? Oh, boring. It's completely boring. Isn't it? Your studies, your classes, everything is very much boring to me, ma'am. Why are you saying so? Why are you asking so? You know it very well. Then also you are asking, how is the classes? Yeah, classes will be a little bit of boring. That is sure. But those who can overcome this boring, those who can go through the topics, those who can study everything will reach to the top. That is the way to the success. Okay, so you also have to go through all these steps. Don't forget it. Okay, so we were discussing about sharing of charges. Okay, that topic is over. And similarly, another particular topic. The topic is, may I go? Okay, the effect of dielectrics in a capacitor. The topic is a particular topic. Effect of dielectrics. Effect of dielectrics. So, suppose there is a capacitor. Okay, its capacitance is C. Suppose the capacitor is connected to a battery and is charged. The battery provides a potential difference of V volt. And as a result of this potential difference, the capacitor stores a charge Q. So, there is a capacitor of capacitance C. It is connected to a potential difference of V volt. As a result, it stores a charge Q coulomb on it. Okay. So, capacitance C, charge Q, potential difference V are given. Now the question is, now the topic is, a dielectric medium of constant K is introduced. Now, a dielectric medium of constant K is filled in the space between the plates of the capacitor. You have to find, if the medium is filled, what happens to its capacitance? What happens to the charge stored? What happens to the potential? What happens to the electric field? What happens to the energy stored? Okay, if we fill a medium of constant K here, that is, now the capacitor is like this. The capacitor is filled with a medium. Okay, and in first case, suppose the battery is connected now. Battery is connected as such. The battery is connected as such. That is, battery of potential difference V is connected as such. Okay, what happens? Tell me. What happens to the capacitance? The new capacitance, we can write here, new capacitance C dash is equal to, what was the capacitance of a parallel plate capacitor? Yes. Whether this is the equation you have said? Yes. What is the capacitance of a parallel plate capacitor? epsilon 0 A by D. And if a medium is filled, epsilon 0 becomes K epsilon 0. So inside a medium, it becomes K epsilon 0 A by D. Isn't it? So we have written it as K times initial C. So what happens to the new capacitance? The new capacitance becomes K times the initial C. Okay. When the capacitance increases, what happens to the charge? Capacitance is the ability to store the charge. When my ability to store charge increases, whether charge increases, surely increases, because the battery is now to doing work. It is now to providing potential. So what happens? It again increases its charges, further stores the charges. So new charge becomes Q dash is equal to K times Q. C is equal to, here we will write, now this may be over. C is equal to Q by V. C is directly proportional to Q. Okay, so as capacitance increases, there is the external agent. Now too, the external agent is connected as such. It is doing continuously work. As a result, more and more charges will be stored. How much charges? K times initial Q will be stored. Then what about the new potential difference PD? This is the potential difference V dash. Whether the potential across the plates, this is positive potential, this is negative potential. Whether the potential difference across the plate changes since the C and Q change? No, because now too the potential difference is provided by the same battery. Whether you have changed the battery, whether you have changed that battery, removed that battery and a new battery is connected here to change the potential difference? No, the potential difference remains the same because the battery is same. So it is V itself. Clear? Potential difference was provided by the external agent. The external agent is now to remain as such. So no change in the potential. If there is no potential change, what about new electric field? Electric field E dash. We know potential is the negative integral of E dot dl. If potential is same, distance is same, whether E changes, potential same, whether you have changed the distance between the two plates? No. Distance same, potential same. That is E itself. Initial E itself. No change. No change. Then new energy. What about the new energy? Energy equation is, there are several equations. We are just taking half CV square. Capacitance increases to K times, but potential remains the same. So new energy, we can write it as half Kc into V square, or K times initial energy. Is it clear? So what about the energy? Clear. C increases to K times, no change in potential. So energy also increases by K times. So energy, new energy. How to take the energy? May I write it as U? U dash is equal to, U is the symbol for energy now. Okay. U dash is equal to K times U. Is it clear? Why I converted the symbol of E for energy? Because just above that, we have taken E for electric field intensity. That's why energy is now taken as U. Okay, you may take any letter for that. Okay, so U dash is equal to KU. That means when a dielectric medium of constant K is filled, the capacitance increases by K, the charge increases by K, whereas the potential and electric field intensity remains the same because it was provided by, they were provided by the external agent. Okay, then the energy increases by more charges are stored. As more charges are stored, more energy is stored. Okay, is it clear? So there, that is the effect of dielectric when the battery is connected as such. Now the second is effect of dielectric when the battery is disconnected. Now the battery is disconnected. That is, we have removed the battery. The capacitor of capacitance C, charge Q and potential V is now disconnected from the battery and the medium is filled like this. Medium of constant K is filled like this. What happens to the new capacitance? Tell me. New capacitance C dash. Medium is increased. Medium is filled, sorry. So we can write C dash is equal to K epsilon 0 A by D. Now too it increases by K. No change. Kc. That is its capacitance to store the charges increases. Its capacitance to store the charges is increased. But whether there is battery to provide extra charge, it has the ability to store the charge. But whether there is any battery to provide extra charge, no external agent. So even though capacitance increases, whether it stores extra charge, no, the charge remains the same because there is no one to provide him the extra charge. Is it clear? If so, what happens to the new potential difference? Look, now for the capacitance C dash, the charge stored is Q. In earlier case, for the capacitance C, the charge was Q. Now for higher capacitance, charge remains the same. So what is the equation? C is equal to Q by V. Q remains constant. C is inversely proportional to potential. Q is constant. So C is inversely proportional to potential. What happens? As capacitance increases, potential difference across the plates of the capacitor decreases by the same value, K. Since the capacitance increases by K, the potential difference across the plates of the capacitor, not of the battery, but across the plates of the capacitor decreases by K. Is it clear? Okay. Now, if potential difference decreases by K, the electric field intensity, which is minus dV by dl, what happens? No change. No change in the distance. Potential difference decreases by K. Energy also. Sorry, electric field also. Sorry. This is electric field intensity. Electric field intensity also decreases by K because the relation between electric field intensity and potential difference is this much. Okay, and finally, what happens here, right here? What happens to the new energy U dash? The next one, energy U dash. What was the equation? Half C V square. Now the equation becomes half C dash V dash square. C dash is Kc. It's okay. But V dash is V by K, the whole square. Okay. One of the K is removed. Even though it becomes CV square by K, the energy decreases by, the energy U decreases by K. Is it clear? Look on the video. Two cases. When the battery is connected as such, when the battery is disconnected. When the battery is connected, capacitance increases by K, charge increases by K because the battery is providing the same potential now. The field remains the same and the energy increases by K. But when the battery is disconnected, what happens? Even though capacitance increases by K, there is no one to provide the extra charge. Okay, so the charge remains the same. Then what happens? For a higher capacitance, Q charge is stored. So the potential across the plate decreases by K. From the equation, C is equal to Q by V. Since the potential decreases by K, automatically the electric field intensity also decreases by K because it is 1 by electric field intensity is the negative potential gradient. They are directly proportional. And also energy decreases by K according to the equation half CV square. Okay. Is it clear? Pause the video and take the notes. So hoping all of you understood what is the effect of dielectrics for a capacitor. It has two different types, when it is connected to the battery and when it is connected to or disconnected from the battery. Okay, hoping all of you understood this. And today we are going to winding this video from this at this topic. Until the next topic, you have to study well. Okay, see.